Welcome to this explainer. Whether you're just starting out or you've been coding a while, familiarizing yourself with Python's native built-in data types is absolutely essential. To make these concepts really stick today, we're going to frame Python's fundamental data types as a fascinating royal kingdom, drawing directly from Fabrizio Romano's incredible insights in Learning Python. Mastering these structures is the absolute key to successfully representing, manipulating, and combining complex information in your code.
So, let's quickly check out our map of the kingdom for today. We'll start with the great divide of mutability, meet the Python numbers, check in with immutable sequences, pay our respects to the royal family of lists and dictionaries, and finally, get to know the guards, the set types. Let's jump right in. Section 1. The Great Divide. Mutable versus immutable.
Right off the bat, before we even meet the citizens of our kingdom, we have to understand the fundamental law of Python physics. It really comes down to one critical question. Can the value of an object actually change once it's created? If it can, we call it mutable. If it absolutely cannot change, it's immutable. And understanding this distinction is absolutely vital. It literally dictates the code you write and how Python manages memory behind the scenes.
This is a brilliant way to picture what's happening under the hood. When we write age equals 42 in our code, we aren't creating a little box named age and stuffing the number 42 inside it. Nope. Instead, Python creates an immutable integer object with the value of 42. The name age, it just acts as a pointer, pointing directly to that specific object in memory.
And here's where it gets really interesting. What happens when we quote-unquote change that value? Well, if you type age equals 43, you aren't actually mutating that original 42 into a 43. Since integers are strictly immutable, Python goes and creates a brand new integer object for 43, complete with a totally different memory ID, and just moves our age pointer over to it. On the flip side, mutable objects, like maybe a custom person object, they can change their internal state. You update fab.age to 29, and the memory ID for that person object stays exactly the same. No new object needed.
Section 2. The Citizens. Python Numbers.
Let's meet the hard-working foundational units of our code. Python has amazing out-of-the-box support for numbers, which makes total sense when you remember its creator has a master's degree in math. Now, take a look at this massive wall of digits. No, that is not a typo. That is literally 2 to the power of 1024. It perfectly proves that Python integers have an unlimited range. Unlike some other languages that put a hard cap on your numbers, Python's integers are limited only by your computer's available memory. Pretty wild, right?
Now here's a fun little quirk of the kingdom. What do you think you get if you add 1 plus true? Well, the secret here is that booleans, true and false, are actually a sneaky subclass of integers. In any mathematical context, Python just upcasts them. True behaves exactly like a 1, and false acts like a 0. So 1 plus true actually results in an astonishing 2.
Let's talk about reals, or floating point numbers, which we use for decimals. If you calculate 3 times 0.1 minus 0.3, you'd logically expect a solid 0, right? Well, instead, you get 5.55 times 10 to the negative 17. Why does it do that? It's because real numbers use the 64-bit double precision floating point format. We have a finite amount of memory trying to store infinite fractions, so we get these tiny little approximation quirks. It might seem super small, but believe me, this absolutely matters if you're calculating finances. If precision is everything, Python gives us a specific decimal type to avoid this exact headache.
Moving right along to Section 3. The Unchanging Messengers. Immutable Sequences.
Strings and tuples. These are our messengers, delivering textual and grouped data. And as their category implies, these sequences absolutely cannot be altered on their journey. Strings handle our textual data using Unicode code points. But let's really focus on tuples for a second. Sequences of arbitrary Python objects separated by commas. You might be wondering why even use a tuple. Well, because they unlock some incredibly elegant patterns, like returning multiple values from a function. Or instead of writing 3 clunky lines to swap variables using a temporary container, tuples let us swap A and B in a single, beautiful line of code. A, B equals B, A. Boom. It's that kind of elegance that makes Python code so satisfying to write.
Section 4. The Royal Family. Lists and Dictionaries.
We've arrived at the absolute core of our explainer, the highly versatile royal family. Literally everything you do involves managing data, so mastering these two structures is essentially your key to the kingdom.
Romano uses this brilliant metaphor, and it hits the nail on the head. The dictionary is the king of data structures in Python. I guess this makes the list its rightful queen. Let's start by paying our respects to the queen.
Lists are far and away the most common mutable sequence. They are incredibly flexible. Because they're mutable, you can change them on the fly after they are created. We generally use them to store collections of homogeneous objects, but hey, they'll happily store heterogeneous data too. They come fully loaded with built-in methods. You can add data with append, seamlessly sort complex items, and dynamically pull data out with pop. They truly are programming royalty.
And sitting right beside her is the king, Python dictionaries. A dictionary is the only standard mapping type in Python. And get this, it actually forms the backbone of every single Python object behind the scenes. Dictionaries are the absolute monarchs of data retrieval. They're mutable objects that give you incredibly fast access to values by mapping them to unique keys. It's an order 01 operation, which is blazingly fast. But that brings us to a very important requirement for those keys.
Section 5. The guards. Set types. To finish our tour, we encounter the royal guards, sets and frozen sets. These are specialized collections used for rigid testing and math. But to really understand sets and to fully understand dictionary keys from our last section, we have to grasp one final concept, hashability. This is absolutely critical. An object must be hashable to be a set member or a dictionary key. The golden rule? For an object to be hashable, its hash value can never ever change during its lifetime. That means only our immutable citizens, like integers, strings, and tuples, can be used as dictionary keys or set members. Think about it. If they could change, the mathematical path to find them would be completely lost.
So Python gives us sets, which are mutable, and frozen sets, which are strictly immutable. Both are just unordered collections of hashable, immutable objects. Sets completely strip away all ordering, and by doing that, they give you ridiculously fast membership testing using the in operator, and let you perform rapid mathematical operations like unions, intersections, and differences. They're incredibly efficient.
And there you have it. We have successfully toured the entire kingdom, from the unyielding foundational numbers and elegant tuples all the way up to the versatile lists, the lightning-fast dictionaries, and the mathematically rigorous sets. Knowing when to use a mutable structure versus an immutable one, that is the real secret to writing clean, professional Python code. So now that you understand this royal taxonomy inside and out, which data structure is going to rule your next script? Thanks for joining me on this explainer, and happy coding!